This recording is for in class 82, which is part of Standard 19, Equations of Circles. Today's focus is going to be on learning what the standard form equation of a circle looks like, and then using it to graph or using clues about a circle to write that equation. The equation of a circle has a lot of different parts, so make sure you're copying carefully. The first part is going to look like x minus h inside parentheses squared plus the second part is y minus k inside parentheses squared, and then all of that is equal to r squared. So there are two variables in this equation, x and y, which will stay as variables, but the h, the k, and the r will all be replaced by numbers that represent different features of the circle. To figure out what those represent, we're going to look at a circle investigation so that you can see a circle equation in action, and then we'll see if we can come up with some ideas about what the h, the k, and the r represent for that circle. So if we look at this circle that I have available here, that general standard form equation of the circle is sitting right here, ready to be used. Right now, the h and the k are set up as being zeros, and the radius is set up as being 3. So we see that from the center point out is a 3, and then we've got this circle that's centered at 0, 0. So it looks like the h and the k, since those are both set at 0, are giving us the center of the circle, and then this r, radius value, is showing up on the other side of the circle, but it's being squared. If we investigate the specific equation for the circle that we're looking at, that also looks to be the case. X minus 0 would just be x squared, y minus 0 for the center of the circle would just be y squared, and then 3 squared for the radius of the circle would be 9. So if we pop back over to our notes page, when h and k are both 0, that circle is centered right there at 0, 0, at the origin of the circle. So just remind ourselves that that's the origin of the graph. And we can fill in at the top then that our h and k values are going to be the center of the circle, while the radius is going to be represented by r. So a couple of other things to investigate here as we get started with these equations. The first thing we're going to look at is what happens when h is changed to a positive number. So if we look at our h slider up at the top, if I change that and I make it positive, notice that that circle seems to be moving to the right, which makes sense. If h gets bigger, we think about bigger horizontally as being moving to the right. But something surprising happens down here in the equation. That h is positive 5 right now, but in the equation it's looking like a minus 5. So there are some things to be careful of with the equations of circles, because what you see in the equation is not the full picture of what's actually happening on the graph. When h is positive 5, it's going to look like a negative 5 in that equation. So the direction that the graph moved would be right, but the equation is going to look like x minus h still, and then we'll have our y squared and our r squared to finish out that equation. You can probably guess what's going to happen next, but we're going to investigate it just to be sure. Let's look at what happens when h is changed to a negative number instead of a positive. So if I move this back here to 0, we're back at the origin now. If h becomes a negative number, sure enough, that circle is going to move to the left like we would expect it to. But if we go down here and investigate the equation, again, it looks like the opposite of what we're expecting. That center is at negative 6, 0, but we see a positive 6 in the equation. That positive 6 is coming from subtracting a negative 6. Subtracting a negative changes to be adding a positive. So, what direction did the graph circle move? H was negative, we would expect it to move to the left, and it sure did. But what was unexpected is that equation ended up looking like a plus sign, because when we subtract a negative value, a negative number, that simplifies. When that h is negative, it ends up looking like we're adding a number. In this case it was a 6, so I'm just going to plug a 6 in there so we don't get too confused with our general standard form of the equation. Okay, we'll do more work with that opposite thing that we're seeing when you're in class tomorrow. If that's confusing, don't worry, we'll do some more work with that. But when we move 6 to the right, it looks like x minus 6 squared in the equation. When we move 6 to the left, it looked like x plus 6 squared in the equation. Let's investigate our k quickly and see if that does the same thing or something different. If I put my h back to 0, just so that we're back at the origin, if I make the k positive, it moves up. That's probably pretty expected. Looks like a positive 5 in that center ordered pair, but then again, it looks like a minus 5 in the equation. What happens if we make that k negative? It moves down like we would expect. The center becomes a negative y value, but then look at that. That equation looks the opposite of what we expected again. So at least it's consistent. When the graphed circle is dealing with a positive k, we're going to be moving up. And when we have a negative k, we're going to be moving down. But we're going to end up then with equations where it looks the opposite. So if we moved up 6, it's going to look like a minus 6 in that equation. And if we moved down 6, it's going to look like a positive 6 in that equation. So we'll be careful with those as we're working in class to graph and to write equations tomorrow. But for now, that's it for your vocabulary video notes. We'll see you in class.